The old string in SED's S command is actually a regular expression. A regular expression is a special kind of string that defines a pattern, which other strings are said to match or not match. Regular expressions are also used in other places in SED, which we'll discuss later. Regular expressions are covered in detail in the Lynda course Using Regular Expressions, but for now I'm just going to give you a quick introduction in case you haven't encountered them before. The most basic regular expression is a simple string like /abc/. The pattern ABC matches any other string which contains the letters A, B, and C in that order with nothing in between them. Regular expressions in SED are surrounded by slashes and are always case sensitive. So for example, ABC matches ABC, but does not match ABXC. It does not match AB because there's no C, and it does not match uppercase ABC because it's case sensitive. So for example, in the command sed the to the dukeofyork.txt, the lowercase the is a regular expression that simply matches the letters T, H, and E in that order. The lowercase letters T, H, and E in that order. In addition to matching simple strings, you can use meta characters to create more sophisticated patterns. The period is the first meta character. It matches any single character. So for example, A.C matches ABC. It also matches AXC, or any single character C, but it does not match AC. There has to be exactly one character between the A and the C. Likewise, it does not match AXXC because there is more than one character between the A and the C. So, for example, sed change HE dot to uppercase HEX globally in dukeofyork.txt looks for HE followed by any single character and replaces it with uppercase HEX. So in the first line, you see THE space grand is now replaced with T uppercase HEX grand, and so on. This will look for HE followed by any single character, including spaces, letters, numbers, punctuation, and replace them with the uppercase word hex. The backslash removes the special meaning of any following meta character. So for example, a \C removes that special meaning of dot and now looks for a literal period. So a \C matches a.c. The backslash can remove its own special meaning, such that a \C matches a \C, and the backslash can also remove the special meaning of the slash, which would otherwise terminate the regular expression. A \/C matches a/C. If you didn't use that last backslash, the slash would mark the end of the regular expression, assuming you used slashes as delimiters in the S command. The caret and the $sign match the beginning and end of the line respectively, such that caret ABC matches the first three characters in the line ABCD. But that same regular expression, caret ABC, does not match anything in the line DABC because the first characters of the line are not ABC. ABC $sign similarly does not match anything in the line ABCD because the $sign specifies the end of the line. So this will only match a line that ends with ABC, which ABCD does not. But in the line DABC, that ABC $ matches the last three characters, the ABC, at the end of that line. So, for example, if we look for down and replace it with Fred globally in our Duke of York file, it replaces 4 instances of down with Fred. But if we look for down $sign and replace it with Fred globally in our Duke of York file, then it only catches 2, the 2 in which down appears at the end of the line. There are 2 other occurrences of down within the file, but they are not replaced because they do not appear at the end of the line. Note that the caret and the $sign do not match the first and last characters on the line, but the actual beginning and end of the line itself. In a regular expression, a set of characters between square brackets matches any single character in the set. For example, a square bracket XYZ closing square bracket C matches any string in which an A and a C have exactly one character between them, and that character is an X, a Y, or a Z, a lowercase x, y, or z. This series of characters between square brackets is called a character class. In this case, the characters in the class are lowercase x, y, and z. So a bracket x, y, z bracket c matches axc. It also matches a yc or a zc, but it does not match a xyzc, because the bracketed expression xyz represents a single character chosen from that set. So, for example, we can replace THE followed by the bracketed expression M or Y with uppercase U globally in our Duke of York file. This looks for a lowercase THE followed by a lowercase m or a lowercase y. Wherever it finds it on any line, it replaces that THEM or THEY with uppercase YOU. So for example, in line 3, he marched them up to the top of the hill becomes he marched you up to the top of the hill. But in the line, and when they were up, the two theys are replaced with you. So this SED command replaces them or they with uppercase U. Now note that it missed the uppercase they at the beginning of the last line. Remember, SED is always case sensitive. If you wanted to replace that they as well, you could replace the T in this regular expression with another bracketed expression, uppercase or lowercase t. So now it looks for an uppercase or lowercase t, followed by a lowercase h, a lowercase e, and then a lowercase m or y. And now we catch that first they at the beginning of the last line. If there were an uppercase THEM, it would also be caught. You can also specify a range of characters between the square brackets. For example, a bracket a dash z bracket c matches a followed by any lowercase letter from a to z followed by c. So a bracket a dash z bracket c matches a bc, also a ac, a dc, a xc, and so on. You can use more than one range of characters within a character set. So for example, a bracket a dash z uppercase a dash z bracket matches any uppercase or lowercase letter between the a and the c. It matches a lowercase bc or a uppercase bc. In addition to using a dash z to represent a range of lowercase letters, you can also use 0-9 to represent all of the digits, or a through h to represent uppercase letters A through H. So, for example, we can replace any uppercase letter followed by any lowercase letter followed by any lowercase letter and replace it with uppercase frog globally in dukeofyork.txt. So this is going to look for any case in which we have an uppercase letter followed by two lowercase letters anywhere on the line and replace it with uppercase frog. You'll notice that it replaced the first word on each line, because all of those words begin with capital letters, except for he, which had an uppercase letter followed by a lowercase letter, but that third character was a space, not a lowercase letter, so it was not replaced. And then Duke and York were also changed by this command. The DUK in Duke and the YOR in York matched the pattern, uppercase letter, lowercase letter, and were replaced with frog. Ranges can be combined with other ranges or individual characters between the square brackets. For example, we can replace any lowercase letter or any uppercase letter followed by a space with an asterisk and a space. That only did the first one on each line. Or you can use A through L or RXZ and replace that with, say, a hyphen wherever it occurs on the line. So this will look for any letter A through L or R or X or Z and replace it with a dash. If the first character after the opening square bracket of a character class is a caret, the class matches any single character that is not in the class. For example, caret A-Z matches any character that is not a lowercase letter. It doesn't match ABC. but it could match a space C, a period C, a $Z, and so on. Anything that isn't a lowercase letter. So, for example, if we replace THE bracket caret space bracket with uppercase YOU globally in our Duke of York file, this looks for lowercase THE followed by any character that is not a space and replaces it with uppercase YOU. Note that this command replaces they, them, and the last four characters of neither, but it does not touch the two thes in the line. He marched them up to the top of the hill. Those two thes are not touched because in each of those cases, THE is followed by a space. The asterisk matches 0 or more occurrences of the previous item. The previous item can be a literal character, a period, or a character class. So for example, A, B star, C matches an A followed by 0 or more Bs followed by a C. The A, B star, C matches A, B, 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 C for any number of Bs. It also matches AC. In this case, the number of Bs is 0. But it does not match AXC because everything between the A and the C has to be a B. So, for example, if we look for T dot star and replace it with zoo globally, this looks for a lowercase t followed by 0 or more of any other character and replaces it with the uppercase word zoo. Because the period matches any character, including spaces and punctuation, this replaces everything in each line from the first lowercase t to the end of the line with the word zoo. The only line that is not affected is the first one because it doesn't contain any lowercase t's. Remember, SED is case sensitive. That uppercase T at the beginning doesn't count. Contrast this with T A-Z star zoo globally. This looks for a lowercase t followed by 0 or more lowercase letters and replaces it with the uppercase word zoo. So instead of looking for t followed by any characters, it looks for t followed by any number of lowercase letters. In this case, it replaces them, to, the, top, the, any single word that begins with t. But because the pattern looks for a t followed by any number of letters, it stops when it hits the space at the end and starts over again with the next one on the line because we use the G modifier. Now contrast that with replace T A-Z, 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 star, zoo, globally. What we're looking for now is a lowercase t followed by a lowercase letter, another lowercase letter, and then 0 or more lowercase letters. In other words, any string beginning with a lowercase t and consisting of at least 3 letters or more, and replaces that with the uppercase word zoo. In this case, in line 3, it replaces them, the, top, and the, but not to, to. That to contains only 2 letters. The pattern is looking for 3 letters or more. Note that both of those last 2 examples also replace the last 4 letters of neither in the last line. Nothing in the regular expression says that the lowercase t has to be at the beginning of the word. One note about the asterisk. It applies to the immediately preceding item only. An item usually matches a single character, a single ordinary character, period, meaning any character, or a group of characters in square brackets, meaning a character class. For example, the regular expression A, B, star, C matches an A, 0 or more Bs, and 1 C, whereas A bracket ABC bracket star C matches an A, any number of A's, B's, or C's, and 1 C. And where I say there, any number, I mean 0 or more. So this would match AC, A, ABC, 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 C, or it would match A, A, C, or A, B, 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 C. If you want to repeat a pattern that consists of 2 or more characters, you can enclose it in parentheses. So AB star C matches A, B, 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 C for any number of B's, including 0, or paren AB paren C matches AB, 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 C for any number of AB pairs. Another thing that you need to understand about the asterisk is that it is greedy. Greediness means that an asterisk in a regular expression will match as many characters as it possibly can, even if a following item would also match some of those characters. For example, to match an HTML tag, you might expect that pointy bracket dot star pointy bracket, which matches an opening angle bracket, 0 or more additional characters, and a closing angle bracket would do the trick. But because the period matches any character, including the closing pointy bracket, the dot star will go ahead and match the closing angle bracket of the HTML tag and keep going. For example, if the input line is bracket I bracket italic text bracket slash I bracket, the regular expression bracket dot star bracket will match the entire line, the opening angle bracket and as many characters as it can until it finds a closing angle bracket, not just the initial bracket I bracket. So for example, if we use SED replace bracket dot star bracket with HTML in the standard input, if we try to change italic text to HTML, you might expect this would replace the bracket I bracket with HTML and then the closing bracket slash I bracket to HTML, but it actually replaces the entire line. This is an example of greediness. If you want to write a regular expression that matches only the initial bracket I bracket, one way to do it is to use a negated character class. Bracket, square bracket, caret, closing pointy bracket, closing square bracket, star, closing pointy bracket. This matches a literal opening pointy bracket, and then any number of characters that are not closing pointy brackets, followed by that closing pointy bracket. This regular expression matches only the initial bracket I bracket in the italic text example. So we'll try that. We'll replace pointy bracket followed by square bracket, caret, close pointy bracket, star, close pointy bracket. And we'll do that globally. So what this is looking for is an opening pointy bracket, any number of characters, including 0, that are not closing pointy brackets, and then a closing pointy bracket, and replace that with HTML. So if we use our same italic text input, then it replaces the 2 HTML sequences with the letters HTML. As you've seen, the search string, the first string in SED's S command, is actually a regular expression, and you can use some special characters in it to match patterns rather than literal strings. The replacement string, the second string in the S command, is not a regular expression, but it does have 2 special characters you can use to perform special replacements. The ampersand character in the replacement string is replaced by whatever was found by the search string. This can save typing. For example, you can use replace the with parenthesis ampersand parenthesis globally in dukeofyork.txt. This will look for lowercase the wherever it occurs on the line and replace it with a parenthesis and then that same thing and a closing parenthesis. So it's replaced every the with parenthesis the. Now, of course, you could have done that literally, but the ampersand actually allows you to perform some text transformations that would not otherwise be easy or possible. For example, suppose you wanted to put every capitalized word into parentheses. You can do it this way. Clear the screen to make it clearer. You can do replace bracket A-C bracket followed by bracket lowercase a-c bracket star. So what this is looking for is any uppercase letter followed by 0 or more lowercase letters, and replace that with itself in parentheses. So as you see, this parenthesizes the capitalized word at the beginning of each line and Duke and York. The other special character, well, really it's a character sequence that you can use in the replacement string, is a backslash followed by a number, which I've represented here with n. This special sequence is used together with another special sequence in the find pattern, backslash followed by parenthesis. In the search string, you can enclose parts of the pattern in \parentheses. This doesn't have any effect on what is found, but it does create a substring, which can then be used as replacements in the new string. Just as the ampersand is replaced by whatever was found by the entire search string, the expression \number is replaced by whatever was found by the nth \parenthesis substring. Here is an example. We can replace \parenthesis they, \parenthesis, \were, \parenthesis, with \2, \1 globally. What this is looking for is THEY space WERE, they were. The first word, they, enclosed in \parentheses, is expression number 1. The second word, were, enclosed in \parentheses, becomes expression number 2. This replaces that found sequence with the second expression followed by the first. So what it does is it simply exchanges they and were to turn into were they. The search string works exactly the same as if those \parentheses weren't there, but each \parenthesized word is captured for use by \2 and \1 in the replacement. Now, this example doesn't do anything you couldn't have done with just s, they, were, they. You could have done that, but it misses they were at the beginning of the last line because it's capitalized. Instead of using a literal string, we can use a pattern. We'll replace \paren bracket uppercase or lowercase t HEY \paren \paren WER \paren with \2 \1. So what this looks for is either an uppercase or lowercase they followed by were, and exchanges the two by putting the second found string first. We'll do that to our Duke of York file, and you see that it now exchanges they were to were they, even if the they is capitalized. Of course, the result of this change is no longer correctly capitalized, but it does demonstrate the principle. Here's a somewhat more complicated example. We'll replace were followed by \parenthesis, any letter A through Z star, \parenthesis, and replace that with \1 ed wherever it occurs. What this is looking for is WERE space followed by any number of lowercase letters including 0, and that any number of lowercase letters, the A-Z star, is enclosed in \parentheses, which means it is picked up and replaced on the replacement string with whatever is indicated by \1. So this looks for were followed by any lowercase word and replaces it with that lowercase word and ed. So it changed were up to upped, and were down to down, and were neither with neithered. It's not exactly grammatical, but it does show that even a single \parenthesis sequence in a search string is useful, and shows how you can use literal strings together with patterns and \parenthesis and \number.